Good afternoon, everyone. My name is Brian Olson. So I manage the incident response team at Verizon Media, affectionately known as FIRE, Forensics, Incident Response, and Engineering. Seemed like a solid fit when we had to come up with a fun name. So I'm here today to share an interesting story about a situation we got stuck in a little while ago and how I worked my way out of it. So the situation was we had a recent acquisition, and it was a really exciting acquisition because it was an acquisition of an acquisition of an acquisition. Not a lot of talent left, not a lot of knowledge that knows what's going on a couple companies deep. So the call that we got was that there was a self-reported web compromise. An administrator had been looking at their system and found a couple interesting files on a web server. And then they looked at a different server and said, there's a different set of files on this server, and then another one. Even more different servers. This is odd. So thankfully, they found their way to my team, and we took a quick look at it and go, yeah, no surprise. So there was an Apache vulnerability out there where an arbitrary file upload was on the internet. So lots of people were uploading lots of really fun files. Nothing too crazy, but Metasploit, tons and tons of test files, things of that sort. So some of the challenges in this environment was that we didn't have a lot of historical knowledge. We didn't know what we were getting into. All we knew that there was a problem. So this particular acquisition was hosted in co-location data centers nationwide, a bunch of different data centers owned by different companies. With all public IP addresses, this wasn't something like Amazon, where you have a private side and a public side. It was just a bunch of public IP servers out there. And what did they have backing it? Nothing. No centralized anything. They literally managed the whole thing by SSHing to boxes one by one. That's how they got things done. Probably not the most efficient, but it seemed to work apparently. How about the security side of things? Nah, none of that. So nothing on the host that would be security related, nothing on the network, just a lot of Linux servers in particular, nothing Windows, all Linux servers, all public IPs. Default logs was the only thing we had to work with, and literally one person who had any clue about anything. Thankfully, he had the SSH key to get us into this stuff. So, kind of taking a look at my toolbox and how we're going to handle this situation. The two go-tos, the network side and the host side. The network side was really the easiest one to answer. We didn't have a lot of options. So since these things were in colos, we didn't control the data center. We didn't control most of the networking, anything along those lines. And it clearly wasn't on our corporate network. So we probably could have shipped some equipment to these data centers really quick. However, we didn't really manage it. We didn't control it. We couldn't make them put it in and wire it the way we wanted and that kind of stuff. So we didn't go down that road. We also could have rented or bought equipment and tried to get them to put it in as quickly as possible. But after looking at it and kind of getting the experience of the company in the colos, we just decided not to go down that road. So on the host side, anything along the lines of EDR or anything like that, for our corporate solutions, we had a completely on-prem solution at this point in time. No SaaS, nothing public. Kind of the theory we were working with was our servers don't leave the environment very often. Might have happened once, but not very often. And on the employee asset side, we had an always-on VPN solution. So we literally had nothing exposed to the internet. We had never really thought to put anything on the internet because everything was always on our corporate network. So now that we have a compromise that isn't connected to anything that we own and operate, we had to make some decisions. Were we going to suddenly open up some of our security suite to the internet and kind of sort of see what happens? In theory, it should work. There shouldn't be any problems, but quick risk decision, yeah, we don't want to have bigger problems. We don't want to have new vulnerabilities that we have to deal with. We also probably could have pursued reaching out to some vendors, getting some trial licenses, or scoping a project of some nature, but we were taking on malware. People were on our network doing interesting things, so we just didn't go that route. So I found myself just pondering, well, there's a lot of things to ponder what was going on here, but specifically how to deal with the situation. And it occurred to me that I had already solved this problem a couple years prior. with Ansible. So Ansible is an open source product that's made for basically configuration management. Originally, I believe it was Linux only. However, it now supports Windows. I don't know anything about it. We're not a big Windows shop. We have many, many, many Linux servers, a handful of Linux ones. But it's not a security tool, so it's a little interesting to try and use for this. So how did I get to Ansible? How did this become a tool in my toolbox? Well, if we take a quick look at my team's scope, we own everything end-to-end when it comes to detection and response. Of note, we actually designed and implemented our entire security infrastructure, which is kind of a weird job for a DFIR team. But it didn't exist, we had to make it. And so I'll walk through a little bit of the history of how we came to use Ansible. So we started off with what I'll call bash foo. It got us a really long way. Basically, your standard Linux commands, SSHing to boxes, SCPing files, using the standard text manipulation in a variety of loops to just really loop through different things and achieve what we were trying to achieve. It got us where we were, but we started to encounter some challenges as we grew. We went from dozens of servers to many dozens of servers, and once we got into the hundreds, it started to pose a real challenge for our team. We had to start to look for something else. So what we ended up with was these command lines that look like this on my laptop. You know, we're just taking a list of hosts, cycling through them, doing simple things. Like here the example is going through a list of hosts, SCPing a file, and restarting Apache. So you start to iterate really quickly through things like this. It's not really repeatable. It definitely has some challenges. On the pros side, it's quick and simple. Anybody who works with Linux is pretty familiar with a lot of these commands or learns it quickly. So it's really familiar, it's quick and simple, you can iterate very, very quickly, and there's nothing special required. Bash, right? It's on every Linux box, it's on your Mac, it's kind of a match. So on the con side, it's really not reproducible. The things that I do on my laptop are not reproducible by anybody else on my team in the exact same way. This isn't the most mature solution. There's also really no artifacts or history. Now you could say that there's the bash history, but I challenge anyone to look at my bash history and figure out which thing actually worked. There's a lot to it. Even I can't figure out what usually worked most of the time. It's just easier to start over. Resolve the challenge. So it's also really static. As we grew, when we had a handful of servers, we could push the exact same files, the exact same configurations to our entire infrastructure being tiny. As we got into the hundreds of systems and we had them at data centers all over the world, we had to customize them, especially as the years passed and we had bought different hardware. Lots of things were different, and so we were kind of stuck with static stuff when we were in the bash foo phase. But the biggest killer of them all was serial execution. As you're looping through these for loops and lists of hosts, it's doing it one by one by one. And if you have a long-running operation, long-running even being a couple minutes, looping through a couple hundred hosts, that's half your day. So it sucks the productivity right out of the team. And especially if you're just making a minor change, you go to lunch, come back, realize you screwed up, do it again. It's not great. The next stage, we started to look at DevOps things. I call it DevOps things because I'm not a DevOps person. I wasn't really familiar with any of this stuff, but we had a problem and we had to solve it. So our first take was Chef. It was pretty awesome. Watched a couple YouTube videos, looked at some blog posts. Agent-based, you just install an agent everywhere, build a server, and everything gets updated itself. It's really cool. Until I got into it, I realized it was Ruby. Ruby and I don't have a development background, neither does anyone else on my team. It really wasn't a match. I spent 2 weeks goofing around with Chef and Ruby and realized that this ain't going anywhere. So we kind of just sucked it up, went back to bash foo. Until one day, we finally got to the point where this just wasn't doable anymore. So there's an unfortunate developer that sits across from me. They're like, please, can you help me out? Can you write a simple script that's just a wrapper and does like session management for SSH? I just want to do this exact same thing faster in parallel. So he goes, have you seen Ansible? Take a look at Ansible. Nope, haven't seen it, never heard of it. Back to YouTube, back to watching a couple videos, taking a look at some blog posts. Again, the honeymoon phase. This thing looks Awesome. Let's give it a shot. So agentless, you basically push out everything that you want to do from a single system, and it's based on SSH. If you can use SSH, you can use Ansible. And it has a Python. Python is the back end of it, so everything that's done is readily understandable by a non-developer. So, and I just wanted to throw a Puppet and Chef out here. They are other options. Frankly, we did not get to them. They might be awesome for a similar type of solution. I don't know. So why Ansible? The big thing was it was SSH based. So we were already familiar with how to use it. There's something called ad-hoc mode in it. You can literally pass it the exact same thing, minus the for loop, that we were already doing with SSH. And it just takes that exact same thing and does it in parallel. It is fantastic. So we still got the quick iterations. We still got the fast adoption. In my team, everyone looked at it and goes, yeah, we can do that. That's really simple. This is great. The first week we used it, it really kind of took over everything that we were doing. And there's an ability to abstract some of the details using modules, and the module library is ever expanding. The project, I believe it's owned by IBM, is just exploding. And it's really self-documenting. It's really simple to figure out what's going on, even if you don't know the code per se. So this is just an example. On the left here, you see something, just a code block. Its name is Start the Apache Service. Service is the module here. We feed it 3 things. We feed it the name of the service, the state that we want it in, and whether or not it's enabled. Really simple. And then the bottom is become equal true. If you don't specify a user, it means root. So you want to become root, make sure that Apache is enabled and started. Done. Super simple. And with the module, it really abstracts that it abstracts the details. This will work on any operating system. It doesn't. You don't have to know whether it's a CentOS or Debian or anything else. Ansible takes care of that for you. And then on the right side, we actually feed it a list. Exact same concept. Package is the module. We're setting the state that we want it in, and we're feeding it a list. Install these things, and if they are installed and not the latest package, latest version, upgrade it. Super simple. So the enablers, the things that you need to do to make this work, also simple. The only thing you need is Python. Every single system that you touch with this, the only thing it needs is Python. And then on your own workstation, you need to install Ansible, of course. The things under that are just configuration options. They'll make your life a whole lot easier. But in the Linux world, almost everything has Python on it from the get-go, and if it doesn't, your staff will shortly install it. So it's pretty much works out of the box. The things you need to know are that you need an inventory file. The inventory file is about as simple as it gets. It's a list of hosts, just a list, text-based list of hosts, nothing fancy. The 2 real modes of operation are ad hoc, and this is the way you do things quick and dirty, just kind of like the bash for loops. Or you could use modules, and you can use modules in your ad hoc commands or in something called playbooks. Playbooks is where you start to grow your team's maturity or your infrastructure's maturity, because this is where you start to build out repeatability. You actually document what you're doing so that other people can do it again. This is just a sample of the inventory file of a lab that I built to make this presentation. The 2 blocks that you see here are groups. There's a web server group and a database group. The bolded is highlighted to show you that you can use ranges within an IP. You can use ranges within a host name for your naming scheme. And on the bottom there, you can see that you can just comment this stuff as well. Now, the inventory file can be static or dynamic. In my experience, I've pretty much always worked with a static file. Either the people I'm working with actually have a list of their hosts, and even if they do have a list of their hosts, you want to check that in some way, shape, or form, because it's almost never complete. And the way that I typically have ended up doing that is running nmap. So just run an nmap, get a list of everything on the network, try and connect to it, figure out what's going on. For the dynamic side of things, for the people who are operating in the public cloud, there's other options for AWS and Google Cloud to actually connect to the public APIs, provided you have the credentials, and pull all the information you need that way. So this is just an example of a couple ad hoc commands, and it's just using the standard OS commands. So on the top, you're just running uname-a on all, literally every host that's in the inventory file. So you use the command Ansible, the group all-a is for ad hoc, and then in the parentheses, you pass it what you want it to do. And when you use Ansible in this way, it attempts to connect to literally every single host in the inventory file simultaneously, in parallel. So you will get much, much better performance than going through that serial loop as we did with the bash for loop or while loop. And just to kind of build upon it a little bit, we can also use the web servers group in the next one to restart a service or the following one to run these commands. And this is really good for your first take in the environment. We're trying to see what's going on because it will feed all this output to the shell, and you can just see the output as it's going by. Preferably, you want to use your other commands to look for something you're interested in. So if we switch to taking a look at what we can do with modules, modules is where we start to abstract those details. So on that first one, we're just using the package module as an example. So on the web server group, use the module called package, again in ad hoc mode, and we pass it the two variables, the name of the package that we want to install and the state, which is present. So if Apache 2 was not present, as in not installed, it would install it. If it is installed, it will not do anything. It will just say, okay, it's good. Now, on the service side, we're basically making sure that the service is restarted. Not started, but actually restarted. So Ansible will connect and restart this service. And lastly, on the bottom, we're using a file module in the exact same way. We're passing it the path and file name, and our state is absent. We want to make sure that if this file exists, it will not exist after running this command. And this is just an example of what this looks like. So this is the uname-a running it on all of the hosts in my lab, which at this point was 2 hosts in Amazon. So normally this is colorized. It's really challenging to see if you're not sitting right in front of it. So it's probably still challenging to read, sorry. But normally this is colorized, so you can kind of get a feel for what's what in the output. So back to the incident. So we've got a bunch of Linux servers, hundreds of Linux servers in each data center, a bunch of data centers, colos across the country, and we have to deal with it. So just a little bit of that Ansible know-how, I was able to just quickly sit down and go, all right, let's get a list of hosts. They had a list of hosts. This particular group of folks had a really good host list because they actually connected to them one by one on a regular basis. There might have been other ones that were long lost, but we'll never know. So the Ansible was used to grab the volatile data, and what was actually really interesting and fun, I hadn't done it before, was I used it to collect all the artifacts, download them to my local asset, and label them all, where they came from, what time. So I built a couple playbooks to do this. The first one was called the Triage Playbook, where I was just gathering all the data, getting a list of the processes, getting a list of the network connections, just understanding what's going on out there, and then also downloading and grabbing a bunch of the files, the system logs, the bash history, the web server files. In particular, I was looking at web server files and network data because we knew that Apache was basically allowing anyone on the internet to upload arbitrary files. So this is just a sample of that Triage Playbook. In that first code block there, the most important action that I've learned time and time again, it's called local action. Ansible is made to interact with remote hosts. So in this first one, I'm making an evidence directory, simply making a directory. And I want to make that on my local host. If you do not put that local action there, it will still do it. It will just make that directory on every one of the remote computers and then collect your evidence there, which makes the cleanup more fun. So local action is important. So here we're making a local directory on my laptop. And in the next 2 code blocks, we're basically getting a list of the running processes and writing them to a file in my evidence collection directory. So first one, and it gets a little more dirty here, a little more complex, because this is not what Ansible was made to do, at least as far as I can tell. So we're using the shell module, just like bash. We're going to pass it ps-ef, run this command. And if you were doing this in ad hoc mode, it would spit this out to your display, and you would just see it. But if you do it in a playbook, it will not spit it out to your display. It's expecting to make a change based on the output. It's not expecting you to actually want to consume it. So we're actually going to write it to a variable. We're going to register a variable called PSResult. And in that next one, again, local action, very important, we're going to take the contents of that PSResult variable, and this is where you see a little bit of the Python. We have the dot and then standard out lines in the format that we'd like to consume this data in. By default, it uses JSON everywhere, or at least everywhere that I'm familiar with. So that is going to be the content, and then we're going to have the destination be our artifacts directory. And you'll see there that I used a couple more variables, the first one being the host name. So in my artifacts directory, create a directory for every individual host that I'm connecting to. And then in this particular chunk of the code, we're going to create a file called processlist-timestamp, because I want to know what time I collected this particular information. And as you run this, it'll just create more and more files, which in this particular incident was really helpful as we were taking on more and more files on a regular basis. It helped us to find them. So what does this look like? Pretty simple. This is my Ansible live response folder. Two things to note is that the way that this particular playbook is written, it will retain the remote directory structure. This is an exact duplicate of what is out there on this particular remote host. And during the incident, I had hundreds and hundreds and hundreds of these folders. So I actually wrote the output to two places. I wrote it to the evidence directory, or the artifact directory here, where I wanted to retain this for future information. I also wrote it to a temp directory. All the stuff got written to a temp directory by type. So I took all the netstat and wrote that to a netstat directory, all the process list, wrote that to a process list. And the reason I did that is I wanted to keep this as my basic evidence copy, and then the other one was essentially a working copy, where you could cat all of these files out, rack and stack it, and look for weird things. So the contents of these files basically look like the command line. This is what you would see if you were to run this on the remote host. Now, I did a little bit of finagling with this to make it more human consumable here. But that's basically because all this comes back in JSON. If you prefer to consume it in a different form, you can. So the analysis that I did on this particular incident, because it was an arbitrary file upload in the Apache web directory, it was pretty simple. Look for any file that doesn't exist. They didn't exactly know which files were supposed to be there, but it was pretty quick to figure out with a little bit of frequency analysis. The 5 files that are on every one of those servers, those belong there. The onesie-twosies, none of those belong there. So going through this, you would find a bunch of different interesting network connections. The 90% of those networking connections were on TCP 4444. Anybody who's spent a little time playing around with Metasploit, that is the default of everything in Metasploit. So it's really easy to find the kiddies. What got a little more interesting is people who uploaded other web shells and other things in this environment. There we had to actually go chase down some other things, people who made local users, people who added other things to the system, bonus features. So we basically did a forensic kind of rack and stack analysis of everything. Web directory files, process listing, netstat, that's how we found almost everything. Now what we were doing during this is the triage playbook. This is where we're just collecting all of the evidence. We're collecting all the information we need to figure out what's going on, find all the bad. Now what we were doing on the side is we were building another playbook. We were building the exact same playbook, only in reverse. So instead of collecting all these files, here's a list of things that we need to remove. Users, kill network connections, and remove files. The respond playbook. So in the respond, we broke this into 2 phases, really. Phase 1, stop the bleeding. Patch the servers and reconfigure them so they would stop collecting more malware. Phase 2, full remediation. Take this list of things that we've been collecting and go remove it all. Just clean the whole environment, the big red button. And we did this with using a feature of Ansible called tagging, where you essentially can tag everything in there. So this is what an example of a couple code blocks of the playbook sample look like. On the bottom, you notice there's phase 1, phase 2, and that's just to tag this particular chunk of code with what I'm attempting to do. If you don't provide a tag, it will run the entire thing. Here, we were looking to collect the entire list before we ran it over and over again. So we did it in 2 phases, essentially. Here's a video. So this is the Triage Playbook. So we're using the Ansible Playbook binary, feeding it the YAML file, which is the playbook, and we see it start to run through it. We see exactly what it's doing. The first one is just gathering facts. It's learning about the system so that these modules actually know what they're dealing with. And it tells you the 2 hosts that we're looking at. So we zoom out, we see it start to roll through each task. Note the name. The name is optional. You don't have to use that. If you don't, it will give you the package name. That's not as helpful. This is really helpful. It tells you exactly in friendly human language what it's doing. So if we take a quick second here, we see the 2 hosts and every file that it's downloading from those hosts. So we're going to end up with a complete collection of the data that we're looking for. Here I actually made a mistake. I actually copied a block of code, and we'll see it in a second here, where I'm attempting to download the bash history from the webdir directory. Didn't work at all. So we'll start to see what an error message looks like, and this is it. We see failed, and it tells you basically that it could not find the bash RC file in the web directory. So bottom, we have a play recap. Again, this is normally colorized, so it's really easy to consume. So we see our 2 hosts. We see that 19 tasks ran successfully, no problems. The number of things that was changed was 14. This particular video recording was not the first time I ran it. So 14 things had changed, those log files. 9 or 5 of the other ones had not changed. So we had the 1 failure, 0 skipped, 0 rescued, and 0 ignored. So for the most part, everything that we did ran successfully. There was just that 1 error that I left in there so that it didn't look too crazy. So in summary, this is how we cleaned up an incident with lots and lots of Linux servers with no real orchestration or any other way to deal with it, at least that I could think of in that particular time. So Ansible turned out to be absolutely awesome for live response. It scaled reasonably well. Now, I can't say I've tried to do this with more than 1,000 or so hosts. It may or may not be the perfect solution for every size issue, but it certainly fit this bill. The modules were really helpful. They abstracted all those details, so I didn't have to know the nuances of every single host that I was working with. It collected all those artifacts, tagged them, labeled them exactly the way that I wanted them, and it really allowed me to work at a reasonable scale. And then once we started to build these playbooks, this is something that we can repeat again. We took these exact same playbooks, not these exact same playbooks. These were rewritten for this presentation, but we took those same playbooks that we used during this first incident and reused them a couple times in a couple similar situations. It helped us to mature the program and be able to go in without having to figure this out again. And most importantly, it was quickly customizable. We were able to iterate and find the right answer. So that is Ansible for live response. Again, my name is Brian Olson. If you have any questions, I'm happy to answer them for you.